In this video, I'd like to go over one more of our types of chemical reactions. In this one, I'd like to talk about the double replacement reaction. Sometimes this is called the double displacement, just depends, I think, on your textbook. Most of the more modern ones I've seen have called it double replacement, but it just depends on your textbook. The basic form of a double replacement reaction is often we see two ionic compounds, and I like to have the basic form of AC plus BD, okay, where we see that these cations in these ionic compounds are just swapping anion partners. So we're going to see sort of this C replacing the D and the D taking the place of the C. So like in ionic compounds where I have the positive and the negative things, the positive first, the negative second, so the cations are swapping anion partners, and so we end up with the A paired with the D and the B paired with the C. So that's sort of a basic form to a double replacement or a displacement reaction, depending on what you like to call it. So as an example of this, and I'll just pick two fairly straightforward ionic compounds. Let's say that we have, I don't know, let's do potassium iodide. And I'm not saying that this is realistic, I'm just saying it illustrates the point. So if we have like potassium iodide combining with calcium chloride, and you would recognize this as a double replacement reaction because you have two ionic compounds. This would be something really common to see in solutions chemistry, where you're mixing solutions and perhaps a precipitate forms, and that's where you'd likely see something like this. Let's figure out what these products would be. Alright, so I have my cations, potassium and calcium, and they're going to swap anion partners. So the potassium is going to end up with the chloride, and the calcium is going to end up with the iodide. I'm going to write that. So I end up with potassium chloride and calcium iodide. Just a reminder that when you are combining ions into ionic compounds, that you always need to look at the charges to know how many of each to include in the formulas for the compounds. So for example here, I know that potassium is a 1 plus and chloride's a 1 minus, and so it takes one of each to achieve a neutral charge for the compound. Calcium's a 2 plus, iodide's a 1 minus, and so it takes 1 calcium and 2 iodides to get to that neutral charge. I need all those pluses and minuses to cancel each other out. The universe isn't happy though with what we have here, and so yeah, after doing this and having our formulas correct, we get to balance this as well. So I see that I've got 2 chlorides here, so I'm going to need a 2 here and probably a 1 here. I've got 2 iodides here, so I'm going to need a 2 here and a 1 here, and hope it's all right because I use marker. I've got 2 potassiums, 2 iodides, 1 times 2 iodides here. That's good. 1 calcium, 1 times 1 calcium, 1 times 2 chlorides, and 2 times 1 chloride. That's good. So there's a common double replacement reaction. One thing I might add to this is you get into some cases where, especially with like acid-base neutralization, where it can be a little tricky to balance when water forms from the combination of hydrogen and hydroxide. So I'm going to do an acid-base neutralization and show you a little something that helps me when I'm balancing these, because it can be difficult at times. So let's take something, let's see, fairly straightforward. Let's take hydrochloric acid and combine it with, I don't know, let's do barium hydroxide. Again, each time I write these, I'm having to balance these charges to make neutral ionic compounds in my head. Let's see. And from what we understand of double replacement reactions, we know that the barium is going to end up with a chloride. So we get barium chloride. And now the H and the OH are going to combine to form water. I know that it's tricky if you're balancing this to look at this like it's H2O, and trying to balance those H's can be really tricky. So what I do in these cases where I have an H and an OH combining to form H2O, while I know that H2O is not an ionic compound, I know it's easier for me to balance ions than it is to try to work with the individual elements. And so I'm going to treat this like it's an H and an OH that are just being held together, and H is the cation and hydroxide would be the anion. I know that's not the case. I know I'm forming water, but let's see if this makes my life a little easier. So looking at this, let's see, my H's are fine the way they are. Oh, I've got 2 hydroxides here and only 1 hydroxide here. I'm going to go ahead and put a 2 here and a 1 here. Okay, now I've balanced my hydroxides. I'm aware of that H. I'll take care of that in a minute. With 1 barium here, let's see, and I've got 1 barium here, so that's good. And then I need to balance my H's. Oh, I only have 1 H here, but I have 2 H's here. So I put a 2 here, I have 2 chlorides, and I have 2 chlorides, and so I'm there. Now, when I'm all done, I'm not going to write it like this, so I'm going to get rid of that. But it helps me to balance it a little more easily. So maybe that'll help you too. That's it, double replacement reactions. Typically ionic compounds, 2 of them reacting together to form 2 additional ionic compounds, usually solutions chemistry. So mixing dissolved ionic compounds and we form a precipitate. Yeah, that's often where we'll see these kinds of reactions.